Assalamualaikum students. In this lecture we will discuss how to estimate variance and standard errors of OLS estimators using the calculator in simple linear regression model. So we have given the model where y shows weight and x shows height of different students. So where weight is a function of height. This is our population regression function, and its sample counterpart can be written as y hat equals beta naught hat plus beta 1 hat x. So first of all we need to find the values of beta naught hat and beta 1 hat. The formulas for beta 1 hat and beta naught hat are given as sum of xy divided by sum of x square, which is the formula of beta 1 hat, our slope coefficient, and for beta naught hat formula is y bar minus beta 1 hat x bar, so which is our intercept. So first we need to find the beta 1 hat given as this. In the previous lecture we saw that this equation, this formula can be solved using these expressions using the calculator. So first we need to enter the data on x and y variable, then we can start the calculation. So first go to mode, press 3 for regression and 1 for simple regression, then enter the data, enter the x variable which is 60, comma, then the y which is 140, then press M1 to save the first observation. And now do the same for all the 7 observations. Now I have entered all the 7 values. Now we first find the sum of small xy. This value, to find this we have given the formula. So you need to press the shift and then press 1, then find the sum of xy, and then go to next, and you can see that it is at option 3. So press 3 and then it is minus sum of x, shift 1, 2 multiply by sum of y which is shift 1, and then press next and then press 2. So now divide this with n is 7, so we get the answer which is 83.2285. Similarly, now you can find the sum of small x square. We can find this using this formula, or other method is this is the variation in x. So to find the variation we need two things, the variance and the degrees of freedom. So for this purpose go to shift 2. Here you can see that at option 3 this is the sample standard deviation of x variable. So press 3, and since variance is the square of standard deviation, so press x square, then multiply it with the degrees of freedom. So degrees of freedom here is n minus 1. So n minus 1, 7 minus 1 which is 6. So multiply it with 6, you get the answer which is 17.885. It's 178.857, and the nominator is 832.286. so when you divide, you will get the answer of slope coefficient which is 4.6533. Now next you need to find the mean of y and then the mean of x. Here you can find their means. Go to shift and press 2. Here at option 1 the mean for x is 68.14, and the mean for y, go to shift 2, then go to next, and then at option 1 you can see the mean of y which is 176.714. So here I found the value of intercept which is minus 140.3786. Next we find the r square which is equal to beta 1 hat square multiplied by sum of x square divided by sum of y square. we have already found the sum of x square here, which is 178.857, and then we have already find the beta 1 hat, which is 4.6533. we need to square it. After that, we need to find the sum of y square. How to find the sum of small y square? Here you can see, go to shift and then press 2, then go to next. Here you can see that at option 3, this is the sample standard deviation of y variable. So press 3 to convert it into variance, square it and convert it into variation, multiply it with the degrees of freedom, which is 6. So sum of small y square equals 4159.428. So here you can see that I have found the r square, which is 0.9311, after calculating all these values. Next, our main step is to find the beta 1 hat standard errors, beta 1 hat standard error, which is the square root of variance of beta 1 hat. The variance of beta 1 hat equal to sigma square hat divided by sum of small x square. Here you can see that the sigma square hat is the estimator of sigma square, which is the variance of error term, and according to classical linear regression model assumptions, the sigma square or sigma square hat must be constant because of the assumption of homoscedasticity. So this variance of error term, sigma square hat, is equal to sum of u hat square divided by its degrees of freedom, which is n minus 2 in the simple regression, and this sum of small u hat square, which is the sum of square residual, equals this expression. So you can easily calculate the sum of square residual using this expression, which is equal to sum of y square minus beta 1 hat square into sum of x square. Note that all the values you have already found. So the sum of y square is equal to this term 4159.4286, and the sum of x square you have already found, which is 178.857, and you have already found the beta 1 hat square. Here you have found the 21.6532. this is a beta 1 hat square. You just need to plug these values into this expression, then you will find the sum of u hat square. After finding the sum of u hat square, you need to divide it with the degrees of freedom, which is here 5, and then divide it with the sum of small x square. You will get the answer of variance of beta 1 hat, and after finding the variance, just find the root of the variance. You will get the standard error for beta 1 hat. So I have found the variance of beta 1 hat, which is 0.32048. Then I need to take the square root of this. So by taking a square root, press the square root and then press equal, you will get the standard error, which is 0.566. Next, I will find the standard error of beta naught hat, which is equal to the square root of variance of beta naught hat. The variance of beta naught hat equal the sum of sum of x square divided by n times sum of small x square multiplied by sigma square hat. Note that you have already found the sigma square hat here, and this is the sigma square hat, which is 57.3204. Similarly, you have already found the sum of small x square, which is 178.857, and the sample size is 7, and then you only need to find the sum of x square. So how to find these values? You have just need to find the sum of x square. Here is how to find it. Press shift and then 1. Here is the sum of x square at option 1. Sum of x square, which is equal to 32,683. Now substitute all these values in this formula. You will get the answer of variance of beta naught hat. So I have found the variance of beta naught hat, which is 1496.34. Now I take the square root of this term, which is I take the square root of this term, which is 38.68. Now we have found all the required uh, calculations and values, and the last step, but not the least, is to write all these regression results in a simple and nice format. So here's how to write the regression results. First of all, write the regression equation, which is y hat equals minus 140.3786 plus 4.6533 times x, and then below each coefficient write their standard errors. For example, the standard error for the intercept is 38.68 and the standard error for the slope coefficient is 0.56661. Then below the standard errors write the r square, which is 0.9311. Then you need to interpret all of these regression results. So thanks for watching this video.